Poin 1. Poin 1. Poin 1.
So, a very good morning to each and everyone. I, on behalf of CSIR family and Team Jigyasa, would like to heartily welcome all the principals, teachers, students, and the dignitaries to the first CSIR Jigyasa Student Scientist Connect program. Hello, good morning, everyone. So, today we are delighted enough to have with us the Honorable Director, CSIR NIS, and the Chairman of Burns CSIR Jigyasa program, Dr.
So, very good morning to each and everyone.
We have Dr. Jatin Kalita, Principal Scientist and Nodal Officer of Jigyasa Project, CSIR, and we have Dr. Lakhi Jigyasa, Principal Scientist, CSIR Jigyasa. Jigyasa will be also delivering the popular talk on science. So today, before we begin our program, as in schedule, I'd like to share with you all that the aim of our Jigyasa program is to connect all the schools throughout the northern India, all the 8 states. Till now, we have successfully connected with more than 100 schools from Assam, Nagaland, Arunachal Pradesh, and few other states. So very soon, we will be connecting all the states, all the schools in the northern India, including Sikkim, and we'll provide all the students a platform to speak their mind out. So behind this, like we are very much now today, so we are very much overwhelmed to see the participants. Like before we begin the meeting, before 15 minutes probably we have full the link in Google Meet. So therefore we also have the YouTube channel and the Facebook, so that others who are not able to join us for Google Meet can go to the lectures. So YouTube for very much overwhelmed. We also have a question and answer session where people who are connecting with us through the YouTube or the Facebook can comment below in the Google Meet. So therefore we will also have the reply you through our channel communication like the so this or otherwise you able to join us reply through the Google Meet. So before we begin, so our next agenda is briefing about the Jigyasa program by Dr. Jatin Kalita. So I'd like to just read out a brief biodata of Dr. Jatin Kalita. So Dr. Jatin Kalita did his masters from Assam Agriculture University, Jorhat, taking entomology as elective subject and obtained his PhD from Jigyasa University. He carried out his research work in Jorhat, CSIR Jorhat. He is presently working as a principal scientist and HOD RPVD in CSIR Jorhat. His main research interests are entomophagy and entomotherapy, that is the medicinal and nutritional. So Dr. Jatin Kalita did his masters from Assam Agriculture. He is also worked on insect-based program and slave storage active subject. And he is also like he has many papers on isolation of natural products against type 2 diabetes, oxidative stress, and he has also worked on COPD, and he has also experience in working with others. Till now, he has published more than 50 research papers in reputed peer-reviewed national and international journals. Under his guidance, 5 students were awarded PhD till now, and presently 5 students are pursuing PhD and 1 postdoctoral isolation of natural being. And he has also guided more than 100 students for internship or short-term projects in CSIR. Till now, he has published more. He has lot more, but just I'm briefing his biodata. Now, I'd like to request Dr. Jatin Kalita under his guidance brief about the award Jigyasa program till now, and presently 5 students are pursuing.
Yeah, thank you, Prasad. I will brief about the Jigyasa program, and before that,
guided more than
I welcome our director sir, Dr. Jigyasa to this important meeting and interaction with students. And I also welcome all the teachers, principals, students across northeastern states, because we are happy that we could reach more than 100 schools today. Thank you, Prasad. But unfortunately, many people will not be joining in the Google Meet, but they will be joining through Facebook Live and YouTube. And many students already they have started writing in box that the program should be in Assamese. But this is the just introductory program where the scientific talk will be given, that will be mixed in Assamese and English. But other program we will segregate among the English medium school, Hindi medium school and Assamese medium school. So we will be doing the programs as per the convenience of the students and teacher. But today, as an introductory program, we will go mostly on English, and the scientific talk I requested Loki Zoki already. So he will be explaining in Assamese and English also. So I am just giving about the program, what actually we are going to do under the Jigyasa program in Northeast region. So I have some slides, few slides, so I will just share it. Program will go mostly on English and the scientific talk. Requested if these slides are visible, explaining in Assamese and English also. So I am
Yes, sir. Yes.
about the
Yes, sir. Yes, sir. It is very
what actually we are going to do under the program. Good morning again, one and all. So we are implementing this CSIR Jigyasa program, and we named it as CSIR Jigyasa 2.0 program, virtual lab integration. So Jigyasa program 2.0, why it has come 2.0? That
Yes, sir. Yes, sir. It is very
before this year also we were implementing this Jigyasa program among our all Kendriya Vidyalaya and other schools, but that was mostly not virtual. It was physical. Students were coming here in this laboratory. Our scientists visited many schools and giving lectures and other demonstration. So that is why it was not online, that it was offline. So but now, considering the situation worldwide, the pandemic situation has created us, but that we are facing lots of problems. Students are facing lots of problems to attend the physical classes and even this implementation of this Jigyasa program physically. Therefore, CSIR has made that we should go virtually and it should be like a real life experience for the students. So we are trying our best to make virtual programs as best as real life. So the main objective of this Jigyasa program, actually science motivation Jigyasa program, and therefore the experience of sciences, so that our students can get motivated to take science like a real career in the future endeavor. So in this regard, I just will inform a brief history of our industrial life. The CSIR Northeast Institute of Science and Technology is the only laboratory, R&D laboratory situated in the northeastern region among the 38 different laboratories that have been placed across India. So many of our students, they may not know what is CSIR. That is Council of Scientific and Industrial Research, which is the largest public funded research organization in India, and NIST means Northeast Institute of Science and Technology. Under CSIR, this is the only one lab in northeastern region, and we are covering whole northeastern states. From 1970, this institute is working with students and different science motivation program and different programs suitable for students we are implementing, and basic objective of this type of programs were to expose the young students and research to the activities and achievement in the world of science, to inculcate scientific temper by demystifying science among the students, to instill the sense of pride on the achievement of Indian science into the young minds, and to motivate the students to take up science as career by exposing them to career opportunities in the area of science and technology. So we have conducted lots of programs under this objective. So we have conducted CSIR Summer Research Training Program online during last year, so which was a pan-India program, has got lots of success and lots of visibility in science. We have in our institute, there is a Skills World of Science, where we have kept lots of small events suitable for our students. They can visit, they can see, and they can do some small experiments in the Skills World of Science, where there are two wings, one is passion and another one is excellence for their science career discussion motivation. And also CSIR NIST has identified 18 different students. They are studying from class 9, 8 to 10 throughout the state of Assam, and we have identified them through some competitive examination, and certainly they are from their science economically poor family. They belong to economically poor family, and they are brilliant students, and we have recognized them as a CSIR NIST science scientists, and we are giving them mentoring from our institute as well as some financial assistance for their study. So these are the background, this type of program already we are doing. conducting from our institute, but the family, they belong to economically poor family, and they are brilliant students, and they have recognized them as a CSIR needs science scientists, and we are giving them. So objective of the present program, the Jigyasa 2.0 program, is to develop different do-it-yourself kits so that students can perform basic experiments at home or school and get a chance to explore on their own and learn science. The students will also be given training on how to develop low-cost teaching and learning aids or carrying out science experiments from the naturally occurring ingredients and kitchen-based raw materials. Development of several games, comics, and thick videos, scientific videos, and to make science subject easily understandable for school students in different vernacular languages. These things we will be uploading in our YouTube channel as well as a Jigyasa platform. So for all students, they can access and they can go for all these games, comics, development of videos, games, and creation of mobile laboratory to connect scientific students of interior places of Northeast India and to encourage experiment-based learning and hands-on experience relates science to daily life and how it influences our life. So we will be taking a mobile laboratory to the northeastern states, villages, so that our village students, those who are not of mobile laboratory, the modern laboratories, they will experience that also. Then development of knowledge repository and popularization and hands-on of Jigyasa virtual laboratory to make it accessible from the interior region of Northeast India, that is, it will be available in different platforms, that virtual material for the science, creating awareness of various learning methods such as virtual laboratory, web resources, video lectures, animated demonstration, and self-evaluation. Introduction of plantation and multiplication techniques of different flowers, fruits, vegetables, medicinal and aromatic herbs in different schools through school students. So this is a new item we have incorporated in the program. In each school, we want to develop, establish a nursery of different flower, fruits, vegetable, and medicinal aromatic plants garden, so that the students will come to know what are the different important plants and how to multiply, which will help in their future life, and they can also popularize it to their parents and other villagers, other fellow students or villagers in their village, so that they will come to know the importance of this and how to multiply these important medicinal and aromatic plants. So at present we are doing different content creation of our virtual lab, like games and different animated videos, simulation, and video for scientific subjects like chemistry and other biological subjects. Easy to understand videos on different subjects of science. Then we are making some quiz questions where students can directly interact, they can answer, and they can do from home itself. And there will be some small science comics for the younger students. And these content creations are going on, and already few has already been uploaded in our Jigyasa portal. Easy to understand videos on different subjects of science. Then if we come to develop that different do-it-yourself, that is very important for our students and as well as for the research, and low cost teaching and learning aid, because we have seen in many schools that the youngers, their laboratories or research are getting some difficulty and explain the different scientific experiments while they are teaching science in school. But there are many ways, many expertise we have sourced from Assam and different parts of Northeast. So they will be hiring them how to make different yourself kit and low-cost teaching aid, so that we can explain, demonstrate, then our teachers and students, they can apply to their schools while they are then in schools. Already I have explained that CSIR has aroma and florical services in school campuses, so that we will be implementing in different schools. Wherever the spaces are available, we will be making different, providing planting material. We will be teaching the students how to plant, how to multiply, all these things, so that students will come to know their scientific name, the uses of different plants, students explain the environment as well as their knowledge up to that. So already we have started and different schools they are it is going on. The spaces are available. Then we are doing the science popularization and inculcating scientific temperament among students in different vernacular languages, because many students, those who are from the Assamese medium or local languages, belong to local languages like Bodo, Nepali, Bengali, Assamese, Mizo, Manipuri, Khasi. So we will be publishing different information on latest development in science in different vernacular languages of Northeast India. And already we are working on 1,000 scientists across the globe. We have identified and their major inventions and discoveries through and on digital forms. So it will be distributed among the schools and students. So science popularization activities like online and offline, what we have started today. So like this, and mobile laboratory I have already explained, and already mobile laboratory it is under process. So I think 1 year we will have a mobile laboratory so that we can visit different interior places where students are not getting opportunity digital other bigger laboratory like NIST or any other laboratories. So they will experience this real life laboratory. Then different motivation programs will also be organized for the teachers and parents. So teachers and parents have important role in the students' career, because many of our parents they do not know what will happen to their child if they study science. But we have to give them counseling that what are the prospects, why we need scientists in this country. So all these things we will have different programs on science motivation program for teachers and parents also. So different activities which are proposed under the Jigyasa programs are like this: the simple lectures by experts and discussions among students, teachers, demonstration of scientific phenomena by experts, micro research project for students that will provide to the students they can do sitting in their home, screening of science film, different science film program for students, exposure to computers and their applications, robust aids for science experiments, career guidance on science and technology by different experts, interaction of students with faculty members, expert scientists, and publication of hard and digital books on different aspects of science, including 1,000 famous scientists and their contributions, creation of science and maths club, which is very important. We are going to create some science and maths club through WhatsApp groups, and with this we will have interaction of different activities through science and maths club of students. Then science communication program that we will be doing with different lectures and other competitions, lab specific activities, on-site experiments, visit of scientists to schools, and outreach program. Our scientists, technical officers, they will visit different schools, they will give different lectures and motivation program activities on-site in schools. Then popular lecture series, demo program at schools, then projects of National Children's Science Congress, Vigyan Jyoti, India International Science Festival experiments. So these are different programs in all India level or national level. Our scientists used to conduct, and our students sometimes they do not have any clue how to participate. So that is why we will motivate, we will guide the students and participate in this type of national program. Then we will have an interesting program that scientists as a teacher and teachers as a scientist, and scientists as a student and student as a scientist. So different type of program we will organize so that students have gained lots of confidence on a subject. They can behave like a scientist, and they will explain the different aspect of a particular topic, and scientists will be behaving like a student and they will ask many questions to the students. And this type of program we are planning and we will be organizing. Then there will be different research workshops, students residential program also. We are very much happy to invite many schools and many students to our campus, but due to the present pandemic condition we may not have this type of program, but in future it will be implemented, and we will invite students along with their teachers to stay in our campus and experience the laboratory instruments and all experience. Then mentoring program for adopted ATL schools. So this one we have received instruction from Niti Aayog, Government of India, that where these Atal tinkering labs are there, these schools especially have to mentor, including different KVs, Kendra Vidyalayas. So these programs will be continuously meet here and will be mentored in all these areas of KVs and other regional schools in this region. So there is another one program that will be doing, that citizen science projects for students of class 8 to 12, where different aspects, these are just probably different topics we have identified, but it may come from the teachers or students also, different topic they can choose and they can do different citizen science projects, which is very important aspect for students' life. So we will be conducting at last different science level competition for school students, that debate, extempo speech competition on selected topic in science, scientific writing competition on selected novel issues and problems and sustainable development goals, scientific quiz competition, poster competition, essay writing competition. These should be regularly happening during the course of this program. So this is the in a nutshell what for school students, the programs and activities we are going to do in this Jigyasa program. Thank you. Thank you so much. And problems and sustainable development.
Thank you, sir. Thank you, sir. Thank you so much, sir, for enlightening all the participants regarding the Jigyasa project, its aims and objectives. So our next agenda is the introductory speech by Director, sir. Before I request Director, sir, for this speech, I'd like to read out his brief biodata. Dr. G. Narahari Sastry, sir, is currently working as the Director, CSIR East, Jorhat. Dr. Sastry is a chemist working in the interdisciplinary area, screening chemistry, biology, modeling, and informatics. Our next agenda, Dr. Sastry has been effective in employing computational and theoretical methods solving problems in biology and allied areas. These efforts are embedded not only to provide a robust platform for carrying out research in the CSIR, but also to inculcate culture of development for popular science. Dr. G. Narahari Sastry has made fundamental contributions in the areas such as computational and theoretical chemistry, theoretical organic chemistry and relation mechanisms, software and database development for drug discovery, non-covalent interaction, cooperativity of non-covalent interaction, computer-allied drug design. Under his guidance, 25 people were awarded PhD, 20 postdoctoral fellows, and more than 200 students have done interesting postdoctoral projects. In his career, he has delivered more than 400 lectures, international and national conferences, workshops, and database development for drug discovery. His research was published about 300. He has published till now about 300 research papers at the university, which received over 11,000 citations, 800 each in that of 20 postdoctoral. Professor Sastry was awarded with Shanti Sarup Bhatnagar Prize in Chemical Science in 2011. In his career, he has delivered more than 400. The National Bioscience Award by DBT 2009, which is considered as one of the highest prize of science in India. About 300. He has published. Dr. Sastry is also awarded Swarna Jayanti Fellowship 2005 CST, PM Birla Award 2001, VC Dave Memorial Award 2009, CRSI Medal 2011, and Alexander von Humboldt Fellowship. He is also Sir J.C. Bose National Fellow. He was a visiting professor at IMS Japan, LMU Germany, Jackson State University USA, and various universities in Japan. He is a fellow of National Academy of Sciences, fellow of Indian Academy of Sciences, fellow of Royal Society of Chemistry, fellow of Association of Biotechnology and Pharmacy, Telangana State Academy of Sciences, founder fellow, and Andhra Pradesh Academy of Sciences at IMS Japan. He is also fellow of IMSA FNA, and thus becoming a fellow of three most prominent science academies of India. He was also recently elected as a fellow of Biotech Research Society of India, BRS. With this brief biodata, I'd like to request the Director Sir for his introductory and Andhra Pradesh Academy of Science. He is also fellow of IMSA FNA, and thus becoming a fellow of three most prominent science academies of India. He was also recently elected as a fellow of Biotech Research Society of India, BRS. With this brief biodata, I don't know.
Yes,
I'd like to
something
request
that everybody has
for his
some level
introduction.
of their and we have programming which will help you to look at science in a different way. And I'm so happy to see the young students and teachers who has taken their time to exercise something that one may be wondering that, oh, if this whole program is in Assamese, is it will be so good? And then I will not be able to look at science in a different Assamese. And I'm so happy to see we will have sometimes a problem. Yes, doing things taken their time. We just have to come out with ways. One may be wondering that how to do if this whole program is in our own way. So actually, one has to see that in science, we don't need a large number of people. Even one person can make a big difference. We will have sometimes a problem. You have to realize that if just one book or one pen or one child or one teacher can change the world. This is true. Actually, if you want to change the world, see that in science you need to be a large number of people. Even one person can make. Today in the morning, I heard that in United Kingdom, one book is written or one pen. They have discovered a device that you put that device when there is a crowd, and it will detect if the presence of coronavirus in the air. So what does it mean? You may go to a mall or a cinema hall or in your own classroom. You put that device and then you will know whether anybody has corona in the entire class. Not only that, you will be able to also detect who has the virus. The presence of coronavirus in the way we can solve the problem. Because in
are very important. Sometimes you may not enjoy the subject. As a parent, I am telling you, you are studying, you have to eat well. Sometimes you have to sleep well. That is extremely important. You have to take breathing, how you do the breathing. That is also very important. Find out why you are not. You also have to give a lot of importance to your physical activity. Things that are very important. Sometimes you may not enjoy the subject. As a parent, you should try to find out that what are the things that will improve your. You have to sleep well. Physical, mental, and social well-being. Breathing. Unfortunately or fortunately, we have COVID. That is also very important. But it gives so many challenges. You have to give a lot of importance to your. A lot of people are very upset due to COVID. But the right people will find out how to come up very well during the COVID period. Actually, children like you are really very fortunately upset and stressed due to COVID situation because you are not able to meet friends, you are not able to go to the school, you are locked up at home, and always parents are there. But the right people controlling everything that you do. It's not really nice, right? Studying, online classes, network is not good, and you are not able to see. There are a large number of factors that are upset. So, you also have opportunity. You are not able to go to the school. During COVID, you are locked up at home. You can always, parents are there. Spend some time on you to study. Everything that you do is not there in your syllabus. So, my dear friends, as Jigyasa has mentioned, so we have so many programs. You also have opportunity. Everybody will have programs, but what is important for you is you will have to think about yourself. Spend some time on you to study. Please always believe in your life. That's the only person that can help you is yourself and your parents and your teachers has mentioned. The only person that you can harm yourself, harm is yourself. Nobody can harm you. It is what you think. Will make you better or will make you worse. In your life. God bless you. The only wonderful day, the Ganesh Chaturthi day, and your parents and your Lord Ganesha shower his choicest blessings on you. Because you all know, as children, Ganesha is a symbol for education. It is what you think. And when you pray to Ganesha, according to our mythology, he will probably make sure that there will be no vignas, there will be no obstacles for your life. Somebody will say that, no, this is all religion, this is not scientific. Ganesha, I'm not saying that, I'm not preaching religion here. I'm just trying to tell you that. And when you pray to Ganesha, look at positive things from wherever mythology. Just because it's science, whatever science says, need not be correct unless you understand. Obstacles. You need to have a scientific temper. If something is useful to you, this is all religion. You have to start scientific. Okay, I'm not saying that I'm not preaching religion here. You should be fearless. You should always seek the truth in whatever that you do. Because in life, the most important thing is you have to be truthful and you have to be fearless, and that is the way to enjoy your life. And if you choose science, this is an excellent path. A scientist, and I'm so happy that I am a scientist, and I feel that it's the best thing that can happen to a human being to be a scientist. So, if some of you want to become scientists, I will be very happy to interact with them and see in what way CSIR NEAST can help you through your schools. Thank you very much. Be happy, and I wish you all the best to have the greatest of the great enthusiasm in pursuing your activities. Wish you a very happy Ganesh Chaturthi and have a fantastic day. Jai Hind.
Thank you, sir. Thank you so much, Director sir, for enlightening all the students and motivating them towards science. Now, the next in our agenda is the popular science talk by Dr. Lucky Sekesa. Before I invite Dr. Lucky Sekesa for his popular science talk, I'd like to read out his brief biodata. Dr. Lucky Sekia did his master degree in chemistry from Guwahati University. Then he moved to National Chemical Laboratory, Pune, India, and obtained PhD in chemical sciences in the year 2008. In the same year, Dr. Sekia joined as Scientist B at Advanced Materials Group, Material Sciences and Technology Division, CSIR, NIST, Jorhat. Dr. Sekia is currently working as a principal scientist. His main research interests are on nanomaterial for heterogeneous catalysis, photocatalysis for energy and environment, metal organic framework. He has already published about 60 research papers in reputed peer-reviewed international journals and presented his research work in various national and international conferences. He has in his account 2 foreign patents, and he co-authored 1 book and 2 book chapters. Dr. Sekia is reviewer of many journals like ACS Applied Materials, Nanoscale, Green Chemistry, and many more. He is also an editorial board member of international journal Modern Research in Catalysis. He is guiding 5 PhD students at present, 1 woman scientist, and 4 students has completed PhD degree under his guidance. He has been principal investigator of many projects and created sophisticated facilities like SAM, HR-TAM at CSIR NIST, Jorhat. Dr. Soikia has been involved in science population activities, Children's Science Congress, and imparting training to students. Today, Dr. Soikia will delivering his popular science talk in nanotechnology as frontier sciences. With these brief remarks, I'd like to welcome Dr. Lucky Sekesa for his popular science speech. So, hello, sir.
Okay, I'm sorry, I was muted. Yeah, respected director, sir, Dr. G. Narahari Sastry of our institute, Dr. Jatin Kalita, Dr. Prasvidya, and others in this, project of Jigyasa, and most importantly, the students and faculty members of different institutes who are joining today for this program. I must thank the organizers and Dr. Prasvidya for the nice introduction. And yeah, actually, I think you all must have heard our director, sir, who has given us such an important and motivational speech to motivate all of you at this time of COVID pandemic. And today I will not discuss too much about the technical things, but the very simple way I will just try to make you understand a different subject. And there is not actually, it is a simple subject, but it is combination of different subjects, that is nanotechnology. So let me share my slide first. Prasvidya, is it coming as
Yes,
full screen?
Yes, sir, it is perfectly visible, sir.
Okay.
Loki, it is not full screen.
Wait, I have made it full screen. I think it will come slowly. Prasvidya, at your end, it is full screen?
No, sir, it's not in full screen, but still it's not in full screen, sir.
Wait. Is it coming now?
Not yet, sir.
See, you can unshare and make the full screen first, then share that screen.
Yeah. That I will do it. I think still it is showing not full screen, no?
So still your slides is not in full screen, sir.
Not in full screen. I don't know. I have seen in the other device also.
Someone of you have turned on your microphone. Probably you need to silence it. I request all the participants to mute your microphone. So we have some technical issues.
Actually, the thing is that it is, in my laptop, it is showing full screen. Okay.
So,
Because all tab also I have shared in that way also it is showing maybe.
So you can share it in means as it is like
It is now I have closed that presentation. I will see again.
so till Lucky Jigyasa is like trying to solve the issue. So be patient. We'll be back very soon.
Is it alright, Pasija?
No, so it's still in like we cannot see in full screen.
So in this time, I request all the participants to raise some question in chat box so that we can answer in that question answer session.
So definitely, it's a very nice idea. All of you, dear participants, you have any questions regarding our program Jigyasa, you want to ask anything, just write in the text box. We'll take your questions and we'll try to answer it.
Full screen puri did, but
So, Prasudha, Anshuman, you please note down the questions.
Sure, sir.
Yes, sir. Yes, sir. We are noting.
If people don't have question, I will ask a question and they can write in their chat box. Now it is full screen. You can say who is your favorite scientist and why they are your favorite scientists. But anyway, now it is in very good shape. Please go ahead, Dr. Lucky. Oh,
Hello, sir. Lucky, sir.
yes, is it coming full screen now?
It was in full screen, sir. It was.
It was, now that screen has finished.
all the students can write who is your favorite scientist and why they are your favorite scientists. You can write in your chat box. Or you can also ask questions while sir is making his presentation. Very good. Now it is coming.
So now it is in full screen, sir.
Okay, thank you.
Thank you, sir.
So I'm sorry for this technical problem. So for the particularly for the students, so when the word nano comes to your mind, I think now most of you are aware about different nano products, different things, or you have heard about nano coatings and all. But when I was a student at your age, maybe some 25 years or 30 years ago, I just knew about the nano car of Tata. So I did not know anything about nano. So with the progress in the modern science, with the development of research and in science and technology, there is development in every field of science, irrespective of any branches. Okay, so then people have started thinking about slowly the nanotechnology, and even sometimes it comes to our mind that is nanotechnology the gateway to the future of human beings on Earth. So if anybody is, I can say, speak in Assamese also, অর্থাৎ nanotechnology, nano প্ৰযুক্তিটো আমাৰ মানৱ জীৱনৰ কাৰণে, এই পৃথিৱীত বাস কৰা মানৱ জীৱনৰ কাৰণে ভৱিষ্যতৰ এটা আহিলা হ'ব নেকি, এনেকুৱা ধৰণৰ কথাও আমাৰ মনলৈ আহিবলৈ ধৰিলে। আৰু এই যিটো ইমাজিনেশ্যন, দিছ ইমাজিনেশ্যন where it can take us maybe beyond the sky, তেনেকুৱাকৈ মনত আহিব ল'লে। But this nanotechnology word, if we see, it was used in some of the famous movies. So many of us know about Arnold. You have seen these movies of Arnold, okay? In his movie Terminator 3, he also used that, word nanotechnology. ল'ৰাবিলাকে বহুতে চাই, গতিকে সেই সময়তো তেওঁ কিন্তু 2003 চন মানত আছিলে, তাতকৈ আগত আছিলে এখন মুভি। তাত তেওঁ কৈছিলে যে its arsenal includes nanotechnological transactors. It can control other machines. So আমাৰ চিনেমাবিলাকতো ব্যৱহাৰ কৰিছিলে, ইমানখিনি প্ৰয়োগ হ'বলৈ ধৰিলে। তাৰ লগে লগে যদি আমি চাওঁ যে nanotechnology কিছুমান শব্দ, কিছুমান ভাষা আছে, this nanotechnology languages, আমি কওঁ যে nano bio, nano dots, nano wires, nano electronics, nanobot, nanomaterials, nanochondria. So you have heard about mitochondria. Then what is the exact dimension of these mitochondria, and how can we see all these nano dimensional things? can we see with the help of microscope? এতিয়া মই দুই চাৰিটা কথা তোমালোকক ক'ম যেটো মই নেনো সায়েন্স আৰু নেনো টেকনলজি নেনো বিজ্ঞান আৰু নেনো প্ৰযুক্তিৰ বিষয়ে খুব থুলমূল ধাৰণা দিব বিচাৰিম কিছু পৰিমাণে হিষ্টৰিকেল ডেভেলপমেণ্টৰ কথা ক'ম নেনো সায়েন্সৰ আৰু যে এই নেনো প্ৰযুক্তি নেনো টেকনলজিটো যে প্ৰকৃতিত আছে সেই কথাটো মই ক'ব বিচাৰিম তাৰ লগে লগে সৰুকৈ খুব বিশেষ ধৰণেৰে বিজ্ঞান involved নোহোৱাকৈ without using much of the technical terms. I'll try to make you understand how these nanomaterials or nanoparticles can be synthesized, can be generated, and the different types of application of the nanomaterials in every field and in our day-to-day life. Nano শব্দটো, this nano word is originated from the Greek word nanos, which means dwarf. আমি যে কওঁ কোন মানুহৰ কথা কওঁ আমি চাপৰ মানুহৰ কথা কওঁ so this nanos it's a Greek word which means dwarf the চাপৰ সৰু কথা বুজায় and it is used to describe 1 billionth of something মানে 1 billionth of something হ'ল তুমি একৰ পিছত কিমানটা শূন্য হ'ব একৰ পিছত 9টা শূন্য হ'ব টোটাল 10টা ডিজিট থাকিব সো যদি আমি 1 নেনোমিটাৰ কথা কওঁ আমিতো মিলিমিটাৰ সেন্টিমিটাৰ ডেসিমিটাৰ এইবিলাক আমি কৈছো but if we talk about 1 nanometer not even millimeter not even centimeter or not even one part of 1 millimeter it is 1 millionth part of 1 millimeter so this 1 nanometer is very very small so just the students you can imagine how much small 1 nanometer may be okay আৰু যেতিয়া আমি যিকোনো পদাৰ্থ any material when we think about that scale 1 nanometer scale or 20 nanometer scale or 50 nanometer scale how they behave do they behave like the bigger size materials আমাৰ ডাঙৰ বস্তু নিচিনাকৈ হিহেতি ধৰ্ম দেখায় নেকি এটো মই অলৰেডি কৈছো তুমি যদি স্কেল পাৰ্টত চোৱা স্কেল পাৰ্টত আমি সেন্টিমিটাৰৰ দাগ কটা আছে এই 1 সেন্টিমিটাৰ তাৰ পিছত 1 মিলিমিটাৰ তাৰ এই 1 মিলিমিটাৰ ইমানে সৰু so much small and this 1 millionth time of 1 millimeter so that much small is 1 nanometer and if we compare with our earth তেতিয়া হলো 1 nanometer to কিমান সৰু হ'ব পাৰে এতিয়া মই এটা এক্সাম্পল দিছো 660 অৰ্থাৎ কাৰ্বনৰ এটা এলক্ট্ৰপ বুলি কয় ফুলাৰিন বহুৰূপ বুলি কয় অসমীয়াত সো এই ফুলাৰিনৰ যেটো সাইজ যেটো ডাইমেনশন যদি চাও 0.7 nanometer ধৰা এটা ফুলাৰিনৰ আৰু আমাৰ পৃথিৱীখন হ'ল পৃথিৱীখন তুমি দিঘিয়া যদি তাৰ এটা ব্যাস চোৱা তেতিয়া হলে হয়তো 12756 কিলোমিটাৰ so it is about 1.27 into 10 to the power 7 meter so which is unimaginable times larger than 1 nanometer in nano বিজ্ঞান এতিয়া এই যে সৰু কথা আহিলে আমি সৰু বস্তু পাম the small matters which are in the nanometer scale so their study will be definitely different from the bigger materials bigger size particles আমি ডাঙৰ যদি ওয়্যাৰ এডালৰ কথা কওঁ ডাঙৰ যদি আমি তামৰ এটা পইচাৰ কথা কওঁ কপাৰ আমি যে সোণৰ এডাল চেইন কথা কম যদি সেই সোণৰ চেইনডাল যদি সৰু সাইজত হয় যদি নেনোমিটাৰৰ কথা ভাবা আমাৰ ডিএনএ আমি বডিত থকা ডিএনএ তোমালোকে বডিত ডিএনএ জিন এবিলাকৰ কথা হয়তো বিজ্ঞানত এতিয়া পঢ়িছা সো এটি এই বিজ্ঞানটো এই সৰু বস্তুবিলাকৰ যিখিনি অধ্যয়ন কৰিম যিখিনি ষ্টাডি হ'ব হেতু this is study of the small stuff and that study is nanoscience অৰ্থাৎ সব বিলাক আমি সৰু সৰু সাইজৰ কথা কওঁ আমি সেন্টিমিটাৰ মিলিমিটাৰৰ কথা নকওঁ and all branches of science are involved in the nanoscience it is neither biology nor physics nor chemistry but it is the combination of all branches of science means all biology physics and chemistry are there এইটো এটা স্কেল, এইটো মই কৰা নহয়, মই এইটো নেনো টেকনলজি পাৰ্সপেক্টিভ বুলি এখন কিতাপৰ পাইছিলোঁ এইটো স্কেল। চ' সেই তাৰ পৰা যিটো মই স্কেল উঠাই লৈছোঁ, তাৰ পৰা মই স্কেলটো আনিছোঁ, তাত এইটো 2001 চনত তেওঁলোকে এনেকুৱা এটা স্কেল বনাইছিলে, which they have compared with the natural and the things man-made. মানুহে বনোৱা আৰু নেচাৰেলি যিবিলাক আমি প্ৰকৃতিত যিবিলাক পাওঁ সেইবিলাকৰ ওপৰত তুলনামূলকভাৱে দেখাইছে আৰু তাৰ স্কেলটো কিমান হ'ব পাৰে। আমি যদি চাওঁ, মানুহে আমি সৰু এটা পৰুৱা দেখোঁ, এটা এণ্ট, ইট ইজ এবাউট 5 মিলিমিটাৰ, 5 মিলিমিটাৰ এটা পৰুৱা, আৰু তাৰ লগত আমি কি দেখোঁ, এটা থাম্পিন, এটা 5 মিলিমিটাৰ যাৰ টুপটো থাকে, হেড অফ এ পিন। তাৰপিছত তাতকৈ সৰু কথা যেতিয়া আমি যাম, যদি এটা মাইট, এটা মানে কীটাণু এটা যদি থাকে, যে ডাষ্ট মাইট, এইবিলাক যোনবিলাক এৰ'চলত উৰি থাকে, যিবিলাক তোমালোকে যদি এটা আন্ধাৰ ৰুমত সূৰ্যৰ পোহৰ আহি থকা দেখা, তেতিয়া দেখিবা কিছুমান সৰু সৰু ধূলিকণা উৰি থাকে, ফ্লাই এছ বুলি কয়। চ' তাত সেইবিলাকৰ চাইজটো বহুত সৰু, হয়তো যদি যোনবিলাকৰ ডাঙৰ চাইজ আমি সেইবিলাক খালী চকুৰে দেখিম, বাট দিজ আৰ ভেৰি ভেৰি স্মল, উই ডোন্ট চি উইথ আৱাৰ নেকেড আইজ। চ' ইয়াত ক'ত আছে যে যিবিলাক মাইক্ৰ' ইলেক্ট্ৰ'মেকানিকেল ডিভাইচবিলাক বনাইছে সেইবিলাকৰ চাইজৰ লগত তাৰ চাইজটো একে হয়। আমি যদি একাধিক্ৰমে গৈ থাকোঁ, তেতিয়াহ'লে আমি DNA, ডিঅক্সি ৰিবনিউক্লিক এচিড, DNA, আমাৰ প্ৰত্যেক জীৱৰে শৰীৰত থাকে DNA, আমাৰ যাৰ কেৰেক্টাৰিষ্টিক্স ফিচাৰ্ছবিলাক নিৰ্ধাৰণ কৰে। চ' DNA আমি জানো ৱাটছন আৰু ক্ৰিকে বনাইছিলে তাৰ ডাবল হেলিক্স ষ্ট্ৰাকচাৰ। তাৰপিছত মানুহে বনালে নেনো টিউব। তোমালোকে হয়তো বহুতেই শুনিছা কাৰ্বন নেনো টিউব, কাৰ্বনৰ, তাৰপিছত তুমি গ্ৰেফাইটৰ কথা শুনিছা, গ্ৰেফাইটৰ ছিংগল চিটৰ পৰা গৈ গ্ৰাফিনৰ কথা আজিকালি বহুতে শুনিছে, তোমালোকে শুনিব পাইছা। চ' এটা বস্তু আমি DNA-টো নেচাৰেলি পাওঁ, যিটো চাইজটো হয়তো 2 নেনোমিটাৰ বা 2.5 নেনোমিটাৰ তেনেকুৱা হ'ব, 2 to 2.5, and we see the 2 nanometer diameter of the nanotubes. Is the nanoscale, why these substances are so much interesting? Definitely, these small particles, these small size materials, these nano size materials, they behave differently in comparison to their larger counterpart. একেটা মেটেৰিয়েল যদি সৰু হয় তাৰ ডাঙৰটোতকৈ সি বেলেগ হয়। আমি কাৰ্বনৰ ডাঙৰ যদি এটা এটুকুৰা পালোঁ, কাৰ্বন পালোঁ, ধৰা কাৰ্বন তোমাক ৰড এটা পালা, গ্ৰেফাইট ৰড, তাৰ যদি সৰু চাইজটো যাওঁ, দেট ইট উইল ডেফিনেটলি বিহেভ ডিফাৰেণ্টলি, তাৰ প্ৰপাৰ্টি, তাৰ ধৰ্মবিলাক সলনি হ'ব। চ' এতিয়া সৰু চাইজ হৈ গৈ থাকিব, দেন দিছ পাৰ্টিকল দে এক্সিবিট চাইজ এণ্ড শ্বেপ ডিপেণ্ডেণ্ট প্ৰপাৰ্টি। অকল যে চাইজটো সৰু হ'লেই হ'ব তেনেকুৱা নহয়, তাৰ আকৃতিটোৰ কথাও আহিব। শ্বেপ অফ দ্য পাৰ্টিকলছ অলছ' মেটাৰ্ছ এ লট। চ' এইবিলাক কেনেকৈ সলনি হয়? সলনিটো হ'ব, আমি যদি দেখোঁ সদায়, আমি যিকোনো বস্তু when something comes into our knowledge, first we see with our naked eyes, যিটো আমাৰ চাক্ষুষ এটা ধাৰণা হ'ব, that is optical property. আমি বস্তু দেখিলোঁ, ৰঙা নীলা কালাৰ দেখিলোঁ, তাৰপিছতে আহিব আমি বেলেগ প্ৰপাৰ্টি, যে আমি তাৰপিছত চালোঁ যে সি বিদ্যুতৰ পৰিবাহী হয়নে নহয়, ইলেক্ট্ৰিকেল কণ্ডাক্টিভিটি ফৰ এক্সাম্পল আছেনে নাই, বা তাপৰ পৰিবাহী হয়নে নহয়। তাৰপিছত আমি যেতিয়া গোটা পদাৰ্থ হ'ম, when it is a solid material, then we will see whether it can be melted or what is its melting point, কিমান টেম্পাৰেচাৰত সি গলিব। তাৰ পিছতহে আমি যাম যে কেমিকেল প্ৰপাৰ্টি, ৰাসায়নিক ধৰ্মবিলাক কেনেকুৱা হ'ব, যে এই ৰাসায়নিক বিক্ৰিয়াত ভাগ ল'ব নে নলয়, বা if it takes part in reaction, how it works. Okay, so these properties, these optical, electrical, physical and chemical properties changes in case of the small size particles. Okay, এটা ধুনীয়া এক্সাম্পল আছে যিটো তোমালোকক হয়তো মই লেবৰেটৰীত দেখাব পৰা হ'লে ভাল পালোহেঁতেন। চ' প্ৰত্যেকেই দেখে যে they use this gold ornaments. Gold is normally, this ornament gold is yellow in color, but when this gold is remilled or it is made small size particle, small size, হয়তো প্ৰথম কথা কি হ'ব যে মেকানিকেলি মিলিং, ঘঁহি থাকিব, ঘঁহি যদি তাৰ পৰা অকণমান আমি চকুৰে নেদেখা, which we cannot see with the naked eyes, some particles are drained out from that larger size of the gold chain or gold coin, then you will see that the water becomes little bit pink or purple color. So that means with decrease in size, the color of the material changes. So it is optical property. And for the class say 12 students, if you continue to study basic science after your class 12, even the class 9, 10, 11, 12, all if you study basic science after 12, and if you study chemistry or physics, even in engineering, material science engineering, if you do further research, then you will come to know the fascinating properties of all these small sized materials. So you can do the experiment in lab itself. A melting point, আমি যেটো গলে গলনাঙ্ক অসমীয়াত ক'লে আমি তাক গলনাঙ্ক বুলি কওঁ। So melting point কি? আমি normal আমি দেখিছো, you can see the ice, this ice. So ice melts at what temperature? See, below 4 degree the water becomes ice, and 0 degree it will completely become solid. So when this ice melts, you can see water. If you keep the ice at room temperature, it will melt. Okay, the temperature at which the interatomic কি হ'ব তাৰ পৰমাণু বিলাকৰ বা অণু বিলাকৰ বা আয়ন বিলাকৰ মাজত কি হ'ব এটা বান্ধনী হৈ থাকে, সববিলাক পদাৰ্থতে সেইটো থাকে। They have the attractive intermolecular forces, and যিটো কাৰণে solid হৈ থাকে। তার যেতিয়া সেই ইন্টারমলিকুলার ফোর্স বিলাক ঢিলা হৈ যাব, তেতিয়াই হ'ব সলিড বস্তু এটা গলিবলৈ আৰম্ভ কৰিব। So that is the melting point, and at particular temperature only, so every solid melts. So for different solid the melting point is different. Okay, কাৰণটো কি সেই ইন্টারমলিকুলার ফোর্সটো বেছি থাকিব। So we need to give energy. Okay, আৰু যদি তুমি আইসটো চাবা প্ৰথমতে সারফেসটো মেল্ট হ'ব, অৰ্থাৎ the surface atoms requires less energy. যিকোনো বস্তুৰে ওপৰ ভাগটো সোনকালে গলিব, ভিতৰটো লাহে লাহে গলিব। So সারফেস বিলাক সদায় মানে সিহঁতৰ ইন্টাৰএটমিক or intermolecular force is not much stronger compared to the core. Okay, so যেতিয়া সৰু পাৰ্টিকুলাৰ হৈ যাব, যেতিয়া ন্যানো সাইজত হৈ যাব, তেতিয়া কি হ'ব, সিহঁতৰ কি হ'ব, তেতিয়া মানে সারফেসত বেছিকে থাকিব কোৰতকে। So সিহঁতি ইজিলি মেল্ট হ'ব। যদি গোল্ডৰ কথাকে চাওঁ, মই এক্সাম্পলটো গোল্ড melts at very high temperature, but if it is coming down to the nanometer scale, if it is coming down to the less than 100 nanometer scale, then the melting point also decreases. Okay, so this is just, I know, same thing what I have already told. I'll skip that slide. Now electrical properties, this এটা মই সিধা কন্ডাক্টিভিটি কথাই কম। দেন ইয়াতে মই ছবি দেখাইছো কাৰ্বন নেনো টিউব। ওকে, সো নেনো টিউব তোমালোকে নৰ্মেল টিউব বিলাক দেখিছা, কিন্তু কাৰ্বন নেনো টিউবটো তোমালোকে খালি চকুৰে হয়তো নেদেখা। ওকে, তো কি হয়, this when it is say in the bulk scale, যেতিয়া তাৰ সাইজটো ডাঙৰ থাকিব, it may be conductor or it may not be conductor, it may be non-conductor. Okay, the size সলনি কৰাৰ লগে লগে কোনোবাটো non-conductor may become semiconducting, or conductor may become also semiconductor. Okay, তার কি হয়, এটো যদি তোমালোকে ভালকে যদি তার ডিপটো জানা যায়, আমি ভ্যালেন্স ব্যান্ড আৰু কন্ডাকশন ব্যান্ড সেই তাৰ এনার্জি ডিফারেন্সৰ কথা আছে, কিন্তু হয়তো তোমালোকৰ স্কুলৰ লেভেলত ইমান প্ৰয়োজন নহলেও আগলে তোমালোকে সেইটো জানিব পাৰিবা। বাট ইউ হ্যাভ টু স্টাডি, say you have to, if you take basic science, all these interesting facts you will be learning. Okay, even in engineering also you can learn, but basic science will give you much more than in other branches. Okay, so chemical property কেনেকৈ সলনি হয়, for example the reaction rate, nanoparticles, they are very small in size. Already I told, very high surface area to volume ratio. এতিয়া কথা হল সারফেস এরিয়া কথা আহিলে, মই তোমালোকক একটা এক্সাম্পল কম, হয়তো মই পিছৰ স্লাইডত থাকিব। ধৰিলো এইটো এটা কিউব, A cube to a ডাঙৰ size. Okay, if you can see this cube. So a cube হ'ল ইয়াৰ চাৰিওটা সাইড গোটেইকেইটা সাইড সমান আছে। ইয়াতে ধৰা 2 সেন্টিমিটাৰ আছে। Okay, 1 ইঞ্চি 2 সেন্টিমিটাৰ প্ৰতিটো সাইডত 2 সেন্টিমিটাৰ। So ইয়াৰ যদি আমি সারফেস এৰিয়াটো চাওঁ, ইয়াতে যেহেতু 6 different sides are there, so surface area will be 6a square. And what will be the volume? So 6a square, and the each side length is 2 centimeter. So 6 into 2 square. Okay, 2 square means 4. So it will be 24 centimeter square of surface area. Our volume, it is a cube. It will be 2 cube. 2 cube means 8. So the ratio is 24:8. That means 3:1. That is the surface area to volume ratio. If you dissect this full cube in each side completely, then there will be more number of cubes. Okay, there will be say around how much cube will be there? There will be say 8 cubes. Okay, when there will be 8 cubes, it will be then 8 into 6 into it is now 1 centimeter. Each side will be 1 centimeter. Okay, so 6 into 8 into 1 square. 1 square will be 1. There are 8 cubes, so 6 into 8 means 48. So 48 centimeter square will be its surface area. You come to the volume, there are 8 cubes. So 8 into a cube, that means 1 cube. So 8 into 1 will be 8. Now the surface area is 48. So 48 is to 8 means 6 is to 1. So when the size is small, then the surface area to volume ratio is increasing. 6 is to 1. So from 3 is to 1 with the same material at larger size, it is 3 is to 1. When just you just make it half, it will 6 is to 1. Which, decreasing the size of each cube, the side of those cubes will be also decreasing, and the number of cube will be increasing. So if you go to the nanometer scale, definitely the surface area to volume ratio will be increasing like this. Okay, so I would have been very happy if I could show you, physically in front of you. But so this is practically proven. And I used to tell in the classroom, in your class, you have, say, there are 10 guys, and there are some lean and thin guys like me, and there are some fat guys. Okay, so fat guy will not able to run fast, and the smaller one, the thin one, he will run very, very, very fast. He will do all these naughty things. Okay, that means if you compare it with the chemical properties, the smaller one, the small size will react faster than the large one. Okay, so this is just a comparison. Okay, if we go a little bit deep, then I must say that there are 3 different ways where the nanoscale materials may differ from the macro scale. One is the gravitational force. আমি ডাঙৰ কথা যদি কওঁ তেতিয়াহ'লে আমি মাধ্যাকৰ্ষণ শক্তি কথা কওঁ। পৃথিৱীখনে বৃহস্পতিৰ লগত, পৃথিৱীয়ে বুধ গ্ৰহৰ লগত, বা পৃথিৱীয়ে নিজৰ এটা মাধ্যাকৰ্ষণ শক্তি আছে, এটা নিজৰ এটা আমি ধৰা এটা ডিষ্টেন্সৰ ওপৰত যাব নোৱাৰে, আকৌ তললৈ গুচি আহে। So there is the gravitational force in the large size particles. But when the size becomes small, then the electromagnetic force comes into the picture. তোমালোকে ডাঙৰ হলে আকৌ পঢ়িবা quantum mechanics. Okay, this normally the things were earlier described with the help of classical mechanics. Okay, but when the people are going deep inside of everything with increasing the knowledge now, for the small size particles also, quantum mechanics model are normally used instead of the classical mechanics. So I don't want to describe it more, but if you study more, you will get to know. And already I have mentioned about the greater surface to volume ratio. এইখিনি মই থুলমূলকৈ nano science-ৰ কথা ক'লো, but there are a lot many things actually. Okay, then coming to the nanotechnology, nano প্ৰযুক্তি কি? nano এতিয়া আমি তোমালোকে যদি চোৱা, engineering and technologies are not same কিন্তু. Okay, ইঞ্জিনিয়াৰ হ'ল অভিযন্তাজন, কিন্তু অভিযান্ত্ৰিকটো প্ৰযুক্তিবিদ্যাৰ সৈতে একেবাৰে একে নহয় কিন্তু. ওকে, সো এতিয়া যদি আমি প্ৰযুক্তি কথা কওঁ, যে কিবা এটা বস্তু আমি ব্যৱহাৰিক দিশটোৰ কথা যেতিয়া যাম, যেতিয়া আমি এটা সৰু কাম এটা আমি কৰি আছো, তাক যেতিয়া আমি ব্যৱহাৰিক দিশলৈ গুচি যাম, তাক যেতিয়া মানুহে ব্যৱহাৰ কৰিব পাৰিব, এটা তেতিয়া আমি তাক কওঁ এইটো এটা প্ৰযুক্তি, এটা বিজ্ঞানটো আমি প্ৰযুক্তিবিদ্যালৈ লৈ যোৱাৰ কথাটো কোৱা হয়। সো নেনো প্ৰযুক্তিটো এনেকুৱা এটা হ'ল যে এটা সেই সৰু সৰু যে আমি বস্তুবিলাক বনোৱা যায়, the small things which are being made, this nanotechnology is the art and science of making useful stuff that does depend on the nanometer length scale. এটা সেই আমি কোনোবাটো ইলেক্ট্ৰনিক্সত ব্যৱহাৰ কৰিলো, টিউবৰ কথা ক'লো, আমি ডাঙৰ টিউবত পানী যাব দিওঁ, আমি সৰু টিউবত ধৰা আমি আজিকালি নেনো মেডিচিনৰ কথা আহিলে আমি দৰব যাব দিম, কেৰিয়াৰ হ'ব। ওকে, সো নেনো প্ৰযুক্তি হ'ল নেনো বিজ্ঞানৰ ব্যৱহাৰিক দিশটো, আৰু তাৰ লগত সকলোবিলাক এতিয়া এনাৰ্জি মানে শক্তি বিভাগত যদি ৰিচাৰ্চ গৱেষণা কৰে, মেডিচিন এণ্ড ড্ৰাগছত আহিব, নেনো বায়'টেকনলজি, তোমালোকে হয়তো বায়'টেকনলজিৰ বিষয়ে যদি শুনিছা, তাতো আজি নেনো বায়'টেকনলজি এটা নেনো জৈৱ প্ৰযুক্তিৰ বহুত ব্যৱহাৰ হৈছে। দেন দ্য ডিভাইচেছ, যোনবিলাক মেমৰি আগতে বহুত 256 MB আছিলে, নাও আছে গোয়িং ইনটু টেৰাবাইট, গিগাবাইট। ওকে, সো দিছ গিগাবাইট টেৰাবাইটত যাব, গতিকে তাত মেমৰিটো বঢ়াই আহিলে, মেমৰি তোমালোকে মোবাইল ফোন ব্যৱহাৰ কৰা দেখিছা, মেমৰি বাঢ়ি গুচি গ'ল। all those devices, other devices also, optical engineering. Then coming to the defense and security, কেনেকৈ হয়, বুলেট প্ৰুফৰ কথা আহিলে, বা কোনোবা টক্সিক সাইডত গ'লে তাক কেনেকৈ প্ৰতিহত কৰিব লাগে। দেন বায়ো ইঞ্জিনিয়াৰিং, কসমেটিক্সত তোমালোকে মই এক্সাম্পল হয়তো পিছত ক'ব পাৰোঁ, তোমালোকে সেই ক্লিয়াৰে লগাই থকা জেলবিলাকৰ কথা দেখিছা, বহুতবিলাক ক্ৰীমবিলাকত ব্যৱহাৰ হয়। আৰু দেন নেনো ফেব্ৰিক, অৰ্থাৎ কাপোৰতো যদি নেনো কোটিং কৰিব পাৰি, এণ্টিবেক্টেৰিয়েল কোটিং কৰিব পাৰি, এণ্টিবেক্টেৰিয়েল কোটিং কৰিলে তাত বেক্টেৰিয়াই এটেক কৰিব নোৱাৰে ইজিলি, তেতিয়া কাপোৰটো ভাল হৈ থাকিব, ছেফ হ'ব, আৰু সি নুগুন্ধায়, তেনেকুৱা কিছুমান কথা থাকিব। এতিয়া নেনো টেকনলজিৰ দুটা কথা থাকিলে, ফাৰ্ষ্ট পাৰ্ট ইজ দ্য নেনো চায়েন্স, উইচ আই অলৰেডি আই হেভ টোল্ড। বাট এতিয়া যদি কওঁ যে সেই নেনো চায়েন্সটো যে আমি সৰু সৰু নেনোমেটেৰিয়েলৰ ষ্টাডিৰ কথা কওঁ, সেই নেনোমেটেৰিয়েলবিলাক কি সববিলাক তাৰ all 3 dimension, whether it is necessary to be in the nanometer scale, it may not be. It may if in any dimension, if the material has less than 100 nanometer, okay, then that material may be considered as a nanostructured material. ই হয়তো দীঘলটোত length, breadth, width কোনোবাটোতো যদি 100 nanometer তল হয়, আমি তাক nanomaterial বুলি ক'ব পাৰোঁ। even nano sheet, সে thicknessটো কম। সো আমি 2 dimensional nanostructure, যিবিলাক চেপি যেনেকৈ ৰুটিটো হয়, আটাটোত কি হয়, ঘেঁহুৰ পৰা আটা, আটাৰ পৰা আমি পানীত মিক্স কৰি ৰুটি বনাওঁ। সো যদি তাৰ সাইজটো যদি এইটো যদি নেনোমিটাৰ নাথাকেও, যদি থিকনেছটো নেনোমিটাৰ আহে, দেন ইট উইল বি এ নেনো শীট। ওকে, and nanotechnology, so this researcher, they try to develop the small size materials, and they try to tune their structures for the usable tools and applications. Okay, and at nanoscale, okay, since they exhibit unique properties, then it is very easy to have some exciting tools and products. Okay, বেলেগ কথা আহিব পাৰে, তাৰ লগত মই সংগতি লিখি 2-4টা তোমালোকক দেখুৱাম, য'ত আমি নেনো সায়েন্সটো অলৰেডি হয়তো আছে বা আমি তাক এক্সপ্লেইন কৰিব বিচাৰোঁ। তোমালোকে এতিয়া স্পাইডাৰমেন, ছুপাৰমেন এইবিলাক দেখিছা, বা লিজাৰ্ডবিলাক টাইপত, বা গেকো ষ্ট্ৰাকচাৰ, গেকোৱে কি হয়, ৱালত বগাই যায়। গেকো ৱালত বগাটো একচুৱেলি they have the teeny hairs which helps the gecko to stick on the wall. Then spider silk. So it is one of the strongest, fiber obtained naturally. মকৰাৰ আমি জালখনৰ কথা কওঁ। তাৰপিছতে আছে বহুতবিলাক বাটাৰফ্লাই দেখিছা যোনবিলাকে সিহঁতি নিজে নিজে পাখিটো বা উইংবিলাক ক্লিন হয়, চাফা কৰিব পাৰি, ধূলিৰ মাজেদি গ'লেও চাফা হৈ যায়, পানী পৰিলেও বহুতো শুকাই যাব পাৰে। তাৰপিছত দিছ ডিটেইলছ দে এক্সিবিট ডিফাৰেণ্ট কালাৰ্ছ। অ'কে, ইউ হেভ চিন দেট peacock feeder. So those falls in this optical nanoscience. Yet it dhara pani tupal thakibo, like lotus leaf amar podumor patot pani nathake ba kosur patot pani nathake. Tar pisode hard materials, tough and light taukan base. Yet this they have that nano dimensional arrangements, and those are observed with the help of very high resolution microscopes. It is the nature of say it actually people did not know that nanomaterials they exist in nature or they have used without knowing. In the Roman they prepared this Lycurgus cup, which is now kept in the British Museum, and this cup exhibit different colors. So daylight or when it is light is shone into the cup, it tells me red because there is gold nanoparticle coated inside. But people did not know that it is the nano size. Okay, like that in medieval artisans they used to stain glasses with different metallic powders. তোমালোকে যদি এতিয়া লোহা এটুকুৰা চোৱা, লোহা টুকুৰা একদম ডাৰ্ক ব্ৰাউন হ'ব, যেতিয়া গুৰি কৰি থাকিবা তাৰ ৰংটো redness increases. Okay, so this falls in the optical nanotechnology. So this nanotechnology actually is not many people have used it, but they did not know. তোমালোকে বহুতে হয়তো শুনিছা Richard Feynman. So Richard Feynman, he was an American physicist who won Nobel Prize in Physics in 1959. Okay, and he is the actually person which have just discussed a lot about the small dimensional materials. Okay, size or kotha koisile, and in his famous lecture he about there are plenty of rooms in the bottom. অর্থাৎ তেওঁ বটম বুলি যে কৈছিলে there is plenty of room at the bottom, তেওঁ এইটো কথা নাছিলে তলত পৰি থকা, কৈছিলে যে যদি সৰু সৰু সাইজৰ কথা লৈ আমি ষ্টাডি কৰোঁ ডাঙৰ সাইজ বিলাকৰ বাদ দি, তেতিয়াহ'লে কি হ'ব যে তাত বহুতখিনি কথা জানিবলগীয়া আছে। And he is called the father of modern nanotechnology. Okay, but the thing is that even though he told about small size materials in his 3 books Feynman lecture series, তোমালোকে যদি কেতিয়াবা পঢ়া তেতিয়াহ'লে মোৰ ওচৰতো এটা আছে, now I am keeping it one with me because I read this book in my BSc days and MSc days also, even after that. Okay, and I found it very interesting that in the volume 2 he told about this particularly the low dimensional or small size materials. Okay, but he did not coin the term nanotechnology then. It is one of the Japanese professor Professor Taniguchi. So in 1974 Professor Taniguchi only coined the term nanotechnology, and this nanotechnology, after that people have been started working on materials, small size materials, and they have tried to develop different tools and machines to see those small size materials, and even they have tried to synthesize small size materials of different elements. And one is the famous example is Buckminster fullerene, or it is called buckyball. So the 3 scientists, they from Rice University, Henry Croto and Richard Smelly, and one from University of Sussex, they discovered C60. তোমালোকে হয়তো গম নাছিলে, জাস্ট 60টা কাৰ্বন এটম একেলগে থাকিব, এটা কাৰ্বন এটম নহয় 60টা কাৰ্বন এটম একেলগে থাকিব, আৰু সেইটো কি হয় ডাইমেনশ্যনটো 0.7 nanometer, even it is not even 1 nanometer. Okay, so for that they won Nobel Prize in 1996. Okay, 96 চনত এই তিনিজন মানুহে Nobel Prize পাইছিলে. Then the development is increasing, but nobody wrote about the nanomaterials or nanotechnology, and the first book on nanotechnology was written by Professor Eric Draxler, entitled Engines of Creation. Okay, in India also, আমাৰ ভাৰতবৰ্ষতো নেনো প্ৰযুক্তিৰ কাম, নেনো বিজ্ঞানৰ কাম কিন্তু সেই সময়ৰ পৰাই কৰিবলৈ দিছে। তোমালোকে ভাৰত ৰত্ন প্ৰফেসৰ CNR ৰাম নিশ্চয় শুনিছা। এই প্ৰফেসৰ CNR ৰাও, he is world famous scientist and published more than 1500 papers, research papers in different international journals, and he may be called as the pioneer of nano science and nanotechnology in India. তেওঁ এতিয়াও আছে তোমালোকে জৱাহৰলাল নেহৰু চেণ্টাৰ ফৰ এডভান্স ষ্টাডিজ ইন চায়েন্স এণ্ড ৰিচাৰ্চ, তোমাৰ CSIR কথা যদি শুনিছা, বেংগলোৰত ইণ্ডিয়ান ইনষ্টিটিউট অফ চায়েন্স বেংগলোৰৰ কথা যদি শুনিছা, তেওঁৰ আগতে তাত আছিলে। তাৰ আগত তেওঁ IIT কানপুৰত প্ৰফেচাৰ আছিলে। সেইজন বিজ্ঞানী, সেইজন মানে ৰসায়নবিদ বা প্ৰফেচাৰ, তেখেত ভাৰতবৰ্ষৰ এজন স্বনামধন্য বিজ্ঞানী। আৰু তাৰ পিছত তাৰ পৰ্যায়ক্ৰমে বহুত বিজ্ঞানীয়ে ভাৰতবৰ্ষতো কিন্তু নেনো প্ৰযুক্তি, নেনো বিজ্ঞান, নেনো মেটেৰিয়েল, নেনো পদাৰ্থৰ বিষয়ে ৰিচাৰ্চ কৰি আহিছে। এতিয়া তোমালোকৰ মনত হয়তো আহিব যে আমি তোমালোকে মাইক্ৰস্কোপত মাইক্ৰন চাইজত দেখিব পাবা, হয়তো যোনখিনি বায়'লজি পঢ়িছা, ক্লাছ 11-12ত বায়'লজি তোমালোকে প্ৰেক্টিকেল কৰোঁতে দেখিছা যে মানে আমি যে ষ্টাৰ্ছ চাব বা ব্লাডটো আমি লৈ চাওঁ, okay, but in some cases this pollen grains of the flowers you can see in the practical, but most of you are not able to do that practical now due to the COVID pandemic. Class নাই, practical নাই হয়, but these things are very interesting. So আমি তাত মাইক্ৰন সাইজৰটো দেখিম, কিন্তু যদি তাতকে সৰু সাইজৰ কথা যায় তেতিয়াহ'লে খুব হাই ৰিজলিউশ্যন মাইক্ৰস্কোপৰ দৰকাৰ হয়। আৰু IBM প্ৰথমতে তেনেকুৱা প্ৰথম মেচিন বনাইছিলে যেটো স্কেনিং টানেলিং মাইক্ৰস্কোপ বুলি কয় 1981ত। আৰু তাৰ পিছত ইলেক্ট্ৰন মাইক্ৰস্কোপ আচলতে আগতো আছিল, এনেকুৱা নহয় নাছিল বুলি, কিন্তু যেটো খুব হাই ৰিজলিউশ্যন ইলেক্ট্ৰন মাইক্ৰস্কোপ তাৰ পিছতে ডেভেলপ হৈছে। আৰু এতিয়া কি হয়, ইভেন ইউ কেন সি দ্য ফোটন, you can see single atom like that. This now development is so fast, this science is so interesting, so much interesting. If you want to know more about it, if you read more about this basic science, if you know about material science, nanoscience, you will find a lot of interesting facts, and those things are very interesting. Even in some cases you can correlate with the biological systems. Okay, আৰু আমাৰ স্বনামধন্য বিজ্ঞানী উত্তৰ পূৰ্বৰ ৰাষ্ট্ৰপতি APJ আব্দুল কালামেও কৈ গৈছিলে, the long lasting original color to the peacock has come from God's own creation of nanomaterials coated in a peacock speeder. মই অলপ আগতে কৈছিলোঁ সেইটো কথা, তাত তোমাৰ জিংক অক্সাইড নেনোমেটেৰিয়েল থাকিব। যেতিয়া সাইন্টিষ্টে যেতিয়া তাক আনি এনালাইসিস কৰি দেখিছে সেইটো একচুৱেলি তাতে আছে। So nature has made these nanomaterials. Okay, আমাৰ ফটোসিনথেসিস ক'ত হয়? ফটোসিনথেসিস কোষত হয়, প্লান্ট লিফত হয়। Okay, so আমি মাইট্ৰকন্ড্ৰিয়াৰ কথা পঢ়িছোঁ। এই যে ফটোসিনথেসিস হওঁতে থাইৰয়েড মেমব্ৰেইন বিলাকৰ কথা পঢ়িছোঁ। কি হয় যে লাইট পৰিলে ফুল খাই যায় মেমব্ৰেইনৰ প'ৰবিলাক, তেতিয়া গেছ সোমাই, কাৰ্বন ডাই অক্সাইড সোমাই পেলাই ইন প্ৰেজেন্স অফ লাইট এই এনাৰ্জিলৈ কনভাৰ্ট কৰে, আমি গ্লুকোজ হ'ব বা ষ্টাৰ্চ হ'ব। Okay, so in the thyroid membrane, actually those are also this nano-dimensional pores only. Okay, মই গেকৰ ফিটৰ কথা কৈছোঁ, মই আকৌ নকওঁ, এইটো কিন্তু তাকে মিমিক কৰি পেলাই তোমাৰ এই যে স্পাইডাৰমেনৰ কথা কয়, ছুপাৰমেনৰ কথা কয়। Actually that there is van der Waals interaction. এইটো যে হাই ৰিজলিউশ্যন ইলেক্ট্ৰন মাইক্ৰস্কোপত চাওঁতে এনেকুৱাকৈ দেখা পাইছে। Okay, anyway, so these are Gecko's food structure. I have taken it from a Nature paper published in 2000. Very old, but that is one of the pioneering work that time. Okay. Okay, this I think already I have mentioned. I microfabrication, types of electronics or okay. Then in nature, as I told you earlier, the butterfly wings. So color may be for different reasons. I mean, just দেখো পখিলা রং বেলেগ বেলেগ রং এটা হ'ব পাৰে যে the pigment. Okay, so that chemical যিটো থাকিব এইটো so if it is due to the pigment, it may not change always. Okay, the other reason is the nanostructures. Okay, so this, then if you put some, oil on water, then you can see the rainbow type of thing, this iridescent color. So those are actually the, when light strikes on those, then you can see different colors from the different angle. Okay, and these nanomaterials, so these nanowires, nanotubes, then nano-electrochemical system sensors, all these are the different applications of the modern nanoscience. Okay, then in the energy sector also, I told you that, fuel cell, which uses hydrogen and air as a fuel, that all to produce water as a byproduct. And then in some cases also water molecule can be dissociate to have hydrogen energy. So all these things are there, and this example already I have shown you, this color also I have shown you, and you can synthesize in lab for that. What are the things you need. There are two approaches, one is bottom up and the other one is top down. So bottom up is a kind of chemical method of synthesizing, and the top down, if you take a bigger size, do mechanical milling and make the small size particle to have the nanomaterials. And what we do in the lab, or you can do in the lab also, that for that you need say metal salt if it is metallic, or if it is metal oxide, then also you need metal salt, then some sort of the stabilizing agent. Then for ionic to the zero state metallic state, you need to have some reducing agent, and there are different stabilizers, either solid or say stabilizers like silica, carbon, etc., or clay can be used. Okay, and then reducing agent যোনে তাক ডিজাৰণ কৰিব, আমি solvent বেলেগ বেলেগ ল'ব পাৰোঁ. Water is the best solvent compared to the other solvents. Okay, and these are some of the ligands. Okay, and this is just chemical synthesis, so I don't want to go into detail of the chemical synthesis. These are the nano-sized particles here I am showing. These are obtained with the help of transmission electron microscope. Then another technique is called UV visible spectroscopic technique, which can also use to characterize or to confirm the presence of nanoparticle. This is one nanoparticle, gold nanoparticle synthesized in our lab. Okay, using gold this organic ligand as a stabilizer. Then I told that graphene, for which in 2010 this game and his student Koslov, they got Nobel Prize. It is a single layer sheet of the graphite, which is very interesting, and a lot of researches are going on across the world. Okay, so this, because with the advancement of the study of the small size materials, they have found applications in the information technology, IT sector, energy, as I said. Okay, then even in the, if you play lawn tennis, then you can see this nano titania or nano graphite, which helps to have the stiffness, or which can have more and power racket. And in the golf ball, to maintain the aerodynamics, they coat with different nanoparticles. And in medical application, actually, it is finding a lot of applications now in the drug delivery and all. And you can see some cricket players, they put some white materials. Those are nano gel of titanium dioxide or zinc oxide. But at the time of use, that should not be harmful to our body. So those things are also those toxic part of the small size materials also need to be considered. So you cannot, because it can penetrate to our body, it can harm our body. So optimization of the use is very much necessary, and these are the machines which are available in our institute. If you visit, you can see we have electron microscope, transmission and scanning electron microscope. We have X-ray diffractometer, UV visible spectrophotometer, atomic force microscope. All these are very sophisticated machines, and a lot more studies can be done with the help of these machines. Okay, so I am sorry I took a lot more time. Thank you very much, and thanks to the organizers. And I must acknowledge our honorable director, Dr. Zinor Sastry sir. Thank you.
Sir,
Yes.
sir, please some explain nano application in medicine.
Yes, sir. Can you tell?
You have heard about, see, now this targeted drug delivery. There's a cancer cell, for example. People used to do chemotherapy. Okay, so if you can see the people who undergoes chemotherapy, there is hair fall. Okay, or sometimes they used to give radiation to kill the tumor cells. If if the carrier of the particular drug can be tuned in such a way that it will not harm other cells, only it will kill those cells. It will go, once you put, it will go to those infected site and kill those tissues or cells. Okay, then there will be minimum side effect.
In environmental in this awareness, can you tell this meaning, sir?
What is? Pardon me, can you ask it again? You can ask me in Assamese also, no problem.
Sir, environmental का मैटर है ना सर, एक बार बताओ. Can you tell, sir?
Metal.
हाँ sir.
Metal. See, so if you know that metal, when it is metal, there should not be any oxidation state, means zero oxidation state. Okay, maybe iron rod, if you see iron rod যদি তাত পানী লাগিলে corrode হল অক্সাইড হ'ব পাৰে, তুমি গোল্ড যেতিয়া দেখিবা, so হি কি হ'ব, ইজিলি অক্সিডাইজ নহ'ব, মানে ইজিলি আয়নিক ফৰ্মলে নেযাব, ধাতু হৈ থাকিব, মেটেল হৈ থাকিব. গোল্ড মেটেল, ধৰি লওক গোল্ড আমি নবল মেটেল, প্লেটিনাম, পেলাডিয়াম, মেটেল আছে, সিহঁতবিলাক যেতিয়া জিৰ' অক্সিডেশ্যন ষ্টেটত থাকিব, তাত যেতিয়া তাৰ বাহিৰৰ ইলেক্ট্ৰন, আউটাৰ ইলেক্ট্ৰন যেতিয়া কি বেলেগক নিদিব, it will not lose electron or it will not gain electron, then it will be in the metallic form. And once this bulk size, it is a ডাঙৰ size হৈ থাকিব, and if so it may not behave same as the small size. So if you reduce the size, তুমি যদি সৰু gather, if you go to the goldsmith and they clean the gold ornaments, if you sit with them, you can see that the one when they clean it, the aqueous layer, the liquid portion becomes little bit of very light purple color. Actually, what they do means some of the surface gold are corroded from the surface. Okay, so he will have those are in a very small size and we cannot see with the naked eyes, but that is in the metallic form, and those are small size gold nanoparticle. When it is small size, তেতিয়া কি হ'ব, ইয়াতকে যদি সৰু থাকে, ইয়াৰ the surface atom, ইয়াৰ যদি surfaceত atom থাকিব, atomত ইলেক্ট্ৰন প্ৰটন থাকিব, এটা আমি ইলেক্ট্ৰনৰ কথাই ক'লো. So ইয়াতে সৰু size হ'লে there will be more surface atom on the core. Okay, অৰ্থাৎ গোটেইবিলাক surfaceতে থাকিব. So they will be very much reactive in case of the metals. আৰু যদি ডাঙৰ হয়, there will be more atoms in the core than the surface. Okay, কারণ surface area to যদি কথা already I have explained about the surface area, particular say one cube if you take, so 6 side 6a square. Okay, so surface area to the volume ratio will be more in case of the small size than the large size material. Okay, and what else you want to know? Then it is very interesting actually, you know.
Sir,
Yes.
sir, how nanotechnology used in food?
Used in
Food, sir, food.
food.
Hi, sir.
Food. আচ্ছা, এটা তুমি একটু ন্যানোমেটেরিয়ালটা খাই দিম বললে খাই দিব নোৱাৰা। ওকে, ইউ ক্যানট ইউজ ওয়ান ন্যানোমেটেরিয়াল। ওকে,
Okay.
ফুডত এতিয়া কি হ'ব পাৰে, সো সে এটা বহুত বিলাকে কেমিক্যাল লেয়াৰিং কোটিং এইবিলাক কৰে। ওকে, ফাৰ্স্ট থিং দ্যাট ইউ নো, মাজতে তোমালোকে শুনিছিলানে মনোসোডিয়াম গ্লুটামেট বুলি মেগী খাব দিয়া নাছিলে ঘৰত, মনত আছে?
Hi, hi, sir.
So is a toxic material will থাকিব. So how to detect very easily the devices you can made out of the nanomaterial. Okay, so for the detection, for the sensing purpose, তুমি toxic quality control কাৰণে হয়তো ব্যৱহাৰ হ'ব। Okay, তাৰ বাদে কিন্তু এটা কথা কৈছো যে rheumatoid arthritis-ত আয়ুৰ্বেদিক মেডিচিন এটা দিয়ে, ভস্ম দিয়ে। Actually that somebody they did research on that and found that the Bosmo contains a small amount of the gold particles and which help to heal that pain. Okay, so they have application in medicine. So আমি হেতু খালেও কিন্তু অপকাৰ নকৰে, কিন্তু যদি বেছিকে খাও ই অপকাৰী হ'ব পাৰে। Okay.
So it was a wonderful talk, and we have few more questions from Facebook and YouTube. So here it is, Dulal Sekia. He just wanted to know, can nanotechnology harm people, and how the chemical property changes?
Okay, so see, chemical property changes, as I explained, actually the chemical property means chemical I mean reactivity ka jodi ko chemical property kotha jodi ko, so it's this you know atoms present in the surface in case of the nano size materials is more. Okay, আৰু হেতু কাৰণে actually মই ডিটেইলত যদি ক'বলৈ যাওঁ বলিয়া হয় যেতিয়া মানে UV বা visible light দিলে surface plasmon resonance দেখায়, so this mobility of the surface atoms will be very high. Okay, actually not atom, I can say that electrons. So electron will have a movement to basi hobo, they will be loosely bound. Okay, and you know they have the prone to react more because either they want to leave or they want to attract something. And for example, I do catalysis, for example, আমি রাসায়নিক বিক্রিয়াত অনুঘটক হিসাবে ব্যৱহাৰ কৰোঁ। যদি large size particle থাকিব, then it will be quite stable. But in the case of the small size particle, these catalysts, these metallic catalysts, one example is this Rene nickel, which is used for the reduction of alkene to alkane. Okay, Rene nickel is fine powder. If you put nickel rod, it will not work. If it is nickel powder, then and then only it will work. This electronic property actually changes when the size changes. As I said, in some cases, the valence band, the energy difference between the valence band and conduction band changes, and their activity also changes with change in the energy gap. Okay, so that is one thing. Then another thing is I am just sharing this screen itself. The silver nanoparticle. There are some few years back, people have talked about the silver nanoparticle putting in the refrigerators to kill the microbes, because this gold and silver nanoparticle, they kill microbes. When we take some antibiotic for some diseases, then we feel the secondary effect of loose motion sometimes. So they kill all kinds of say microbes. the harmful as well as the useful microbes. So that's why the doctors prescribes pre-probiotic, or they used to take us this enter germina, which contains uh, lactobacillus, which is present in our card. Okay, so সেই ইউজফুল বেক্টেৰিয়াও মাৰি দিয়ে। অ'কে, এতিয়া তেনেকুৱা ধৰণে যদি আমি ভালৰ ব্যৱহাৰত কৰোঁতে তাত যদি the lethal dose is very high, then it may be harmful. Even there are some eye diseases which were reported for the use of silver nanoparticle. Okay, definitely. So toxicological study of the nanomaterials before using into any animal or human being should be done rigorously. Okay, that's why actually, even though a lot of researches are going on, the nanotechnology, nanomaterials are getting more application in energy and environment sector or electronics rather than getting more application for the human health. But definitely, in 2016, this Ben Feringa, Stoddard, they got Nobel Prize for the nanobot, molecular motors. So that also actually, this is very interesting, discovery, and that falls under this broad spectrum of the nanotechnology. Thank you.
Dr. Pasudra, actually our time has already over, and
Yes, sir, we are running out of
many
time.
people are trying to leave the meeting, but one thing we can do, whatever the question you have already noted along with their name, and we can give one email address to all the participants, or other all the chat box question will be there with us. So I think directly we can post this question and answers in all group, all schools, so that it will benefit the other students also. So whatever the question it is raised here, if it is not possible to answer today due to time, so we can make a question answer sheet and we can circulate all among the group, different groups, so that it will benefit all the students, whoever attending or whoever is not attending. So I think we can conclude this program here, because I have seen that many people are releasing and people are leaving.
Yes, sir.
Because already time is over. So that is a good idea that all the questions we have noted down, and we will make some general question also together on the nanotechnology frequently asked question. Then we will give the answers also, and we will make a 1-page or 2-page question answer sheet. Then we will post to all the schools referring to this program.
Yes, sir.
To all the group, so that they can get their answer.
Yes, sir.
Okay, thank you.
Yes. Thank you, sir. So as Jatin sir said, there are lots of questions and many people wanted to know lots about the nanotechnology. So definitely I just want them to keep commenting. We will take your questions if you have any, and definitely we'll get back to you through WhatsApp or different other medias. So I'd like to thank Lakhi Sekia sir for this wonderful talk covering relevant medias. For example, he has talked about nanotechnology in entomology and molecular biology and all other topics. So thank you so much, sir, for this wonderful talk. And I believe that our participants has learned many things about nanotechnology, its application from your talk. Now I'd like to hand over to Mr. Ansuman Goswami for the vote of thanks.
Thank you. On behalf of Team Jigyasa, I am fortunate enough to offer a vote of thanks. At the outset, we express our heartfelt thanks to Dr. G. Narahari Sastry, the director of CSIR NEST, chairman of Pan India Jigyasa project, for his gracious presence and for his very encouraging speech. We would like to thank Dr. Jatin Kalita sir, principal scientist, coordinator of Jigyasa CSIR NEST, for conducting this program. We would also like to offer our sincere thanks to Dr. Lakhi Sekia, principal scientist CSIR NEST, for accepting our invitation and for his valuable speech. We offer our grateful thanks to all the respected principals, teachers, and students for being present here, spending your valuable time. Without your presence, this meeting would not be successful. We also sincerely acknowledge the help and cooperation received and express our heartily thanks to all who have contributed, either directly or indirectly, in organizing this program. Last but not the least, we thank you all for making this program a great success. Thank you. Have a nice day ahead.
Thank you, everyone.
Thank you. Bye-bye. Thank you and bye-bye.
Thank you so much, all of you, sir.